Hello, students. Got some questions out of the chapter review. So we are in chapter 12 with congruence and similarity with constructions. What a fantastic chapter. And as you can see, a lot of options here for different questions that you could practice with. A lot of them actually showed up on the list in class. Let's take a look today here at question number 6. And so I'll zoom in on this one, but we have a trapezoid. So ABCD is a trapezoid. So again, as you're sketching this out, remember what is a trapezoid. So A to B to C to D, this shape right here is a trapezoid. And that means we have at least one pair of parallel lines. And from the image, we can see that it's BC and AD. And it also tells that EF is parallel to AD. So this line in the middle is parallel to AD. So these two are parallel. Okay, and AC is a diagonal. What's the relationship between AB and C over D? What a fantastic idea here. So a couple things we could do with this. And again, this is completely up to you on how you choose to do this. Let's see here. If I was doing this, I would probably first take the time to say, BC. Let me get some white space first. Let me get a big chunk over here so I can write in it without feeling like I'm constrained. There we go. Okay, so I would probably say BC is parallel to AD because it's a trapezoid. And EF is parallel to AD, and that's given, which also means that EF is parallel to BC, right? And that's by transitivity. If A is parallel to B, B is parallel to C, then A is parallel to C. So there's transitivity. And by the way, the book did at some point in time say a line is parallel to itself for the purposes of transitivity. So it does hold. Okay, and then AC is a diagonal. So now what I have is I could picture, if you wanted to picture this anyway, you could say, okay, well, I definitely have, let me get rid of my drawings over here. Let's mark off some pieces that we know. We know some lines are parallel, right? So I know that this angle up on top is going to be congruent to this angle down here, right? It has to be. And that's because the lines are parallel. And the lines are parallel, so what else would be congruent? Oh, EF is parallel, so this angle right in here is the same as those, and it's the same as this one right in here. Okay, and let's see here, what else do we have? That looks like about it. So if I was looking at this, I'd be looking and saying, you know what I really miss is that side splitter theorem, right? The side splitter theorem was the one where if we had a triangle, right, and I cut it with a parallel line anywhere, then the sides, A over B, are the same ratio as C over D as long as it was split with a parallel line. So it definitely looks like that is happening here. The issue is it doesn't look like a triangle because it looks like just a trapezoid. So just think about this. Take your trapezoid. This will be my hint to moving forward. Take your trapezoid, right? And either this trapezoid is a parallelogram, which is possible, in which case both line sets are parallel, in which case the parallel lines being constructed will absolutely make proportions because they're the same distance apart. If not, then one side is shorter than the other. And what you do is you just extend this up until it meets. And what you have is you actually do have a big triangle. And the triangle then looks like this because that's the trapezoid at the bottom. And then all they did is they drew another line in the middle here, which is also parallel. And so when they're parallel, the sides, whatever we want to call them, X, Y, Z, and U, V, W, whatever they are, right? Then X is to Y as U is to V. So we get these ratios of the sides. So it asks, what is the relationship between A over B and C over D? And what's great is you can now say, I know the relationship between those. Okay. Once again, they seem to have complicated this by adding in X and Y, which does not appear up here. I believe it's because back in the 10th edition, the problem asked about the ratio of X and Y in a different case, but they changed the book but forgot to update the drawing. So gotta love it. You know, hey, one day I'm going to get old and I'll probably forget a bunch of things too. So that could be it. All right, let's move down to the next one then. We've got a trapezoid. Let's see here. So in the following figure, construct a circle so A and B are on the circle and has its center on line L. Interesting. So I need a point. So this is I'm going to give you the thought process. I want you to think about this. You need a point down here so that A and B are on the circle. And that means the distance here has to be the same as the distance here. That's what you need. You need these two distances to be the same. I don't know where that point is, but I do know something about this point. I know this point is the same distance from A and B. Okay. Now, I could have picked another point. Maybe I wanted another point to be the center. Like here, maybe the midpoint. If this was the center of the circle, then it could obviously go through those because M is the same distance from A and B. There are infinitely many points that are the same distance from A and B. Your goal is to find what they all look like. What's the relationship between every point that is the same distance from A and B? And hint, there's a big concept that covers this in section 12.1. So there's my push. Once you think about what kind of shape it is, where every single point on this shape is the same distance from A and B, it will tell you what you need to create. And remember, when they say construct, they mean construct using your compass and straight edge. That's what we're talking about there. Okay. So question 6 and 7 are good to go. And let's see here. Oh, let me stop sharing. Did I get them all? Let's see here. Oh, number 24. I missed number 24. So let's go back to sharing. Here we go. We're going to go to question 24, next page. 24. Got it. Okay. Oceanfront footage. The ocean frontage for the 3 lots is shown here. Assume the non-water property lines are perpendicular to Ocean Drive. Which lot has the highest selling price? Okay. All right. So there we go. So we have 130 total meters here. And it looks like we've kind of split it up into different chunks. Assume, let's see here. More ocean frontage means more value. So we're ignoring a whole bunch, okay? And these are just lots, so there's nothing on there. You have to assume everything else about them is identical. Assume the non-water property lines that do not lie on Ocean Drive are perpendicular. So all that's saying is these pieces that are here, these lines right here are perpendicular to Ocean Drive. Okay, they're perpendicular, all of them. Okay, if they're all perpendicular, guess what? Then they are parallel lines. All the red lines are parallel. And if they're parallel, you can use the side splitter theorem, pretending that this came down and formed a nice triangle. And we have a whole bunch of similar triangles, which means the proportions are similar. So the amount of frontage here and the amount of frontage here and the amount of frontage here, those have to add up to be 130, but they're also going to have to be proportionate to their other sides, because 40 is to 34 as A is to B, and 34 is to 30 as B is to C. So you can use that. And in this case, it's not asking for like how much frontage is actually there. It's not asking you for like what fraction. But there you go. I mean, you could find that if you wanted to using proportions, but it's not asking for that. It just says which lot has the highest selling price, and you should be able to figure that piece out. All right. So that takes care of it. 6, 7, and number 24. Hopefully that's helpful. And if you have other questions, please let me know. I can meet you in Zoom on campus in person. I'll make another video for you if that's what you prefer. Just let me know how to support you. All right, off you go.